know the drill, Sarah, which means you have 5 minutes starting now.
Right, so I'm here to talk to you about the science of predicting volcanic eruptions. In the last 25 years, volcanologists have gotten a lot better at understanding the behavior of volcanic systems and how this translates into eruptive behavior. And you know, why would you want to know that? Well, millions of people live in the shadow of active volcanoes. And for example, when Pinatubo erupted in 1991, this was the biggest eruption this century. They evacuated millions of people on a moment's notice, and there were only like 1,000 deaths in that whole huge eruption. And so if we want to warn people, how do we do that? Well, step 0 is pick out your active volcanoes and have instrumentation in place that allows you to monitor their baseline behavior. And what kind of baseline behavior do we monitor? We look at seismic events, we look at ground deformation, and we look at release of gas from the volcanoes. So we can install a wide variety of instruments at volcanoes in the US and worldwide to understand how they behave normally so that when things start to change, we can understand what that means. And so what are we looking at? Well, we're looking at seismic events, which would be earthquakes. And basically, magma makes a lot of noise when it moves around underground. So we can see magma moving through existing channels, which gives us sort of long period or long slow earthquakes. Or magma can break its way through new rock, which gives you a short, sharp event. We can also track magma bodies by watching earthquakes move in space. So if they move from deep to shallow, you can see a magma body moving towards the surface of the Earth. And we also can see them moving, for example, from the Kilauea crater, which is the massive concentration of red triangles here, east down the lower east drift zone towards Puna, and then after the magma has moved down the rift, erupts in multiple fissures in, basically neighborhoods and into the ocean on the big island of Hawaii just a few months ago. At the same time, we can interpret other kinds of information, such as ground deformation. Ground deformation, basically, if you put a bunch of magma in underground, it takes up space. And as you move it towards the surface, the land surface has to rise to accommodate that magma. On the other hand, if the magma is retreating, you can see deflation. The land surface is no longer supported, so it goes down. And what kind of trajectory do we see? We see potentially, inflation and eruption. After this, the magma is no longer taking up space, so you see deflation. And at Kilauea, you see these cycles over and over and over again. Inflation, deflation, inflation, eruption, and deflation. Alternatively, the magma can just move around, so you can have deflation in one place and inflation and eruption in another place, so you can track it as it moves through the system. We can also try to understand the gas release, where basically magma at depth is like a can of soda. It's got a lot of gas under pressure, and as you bring it up, you pop the cap, a lot of gas comes out of solution and escapes into the air. And so we track especially a noxious gas called SO2, and the more SO2 that's coming out of the system, the more new magma we would say that we have, which allows us to predict eruptive behaviors. And so if you want to put this all together and talk about the 2018 Kilauea eruption, the question is, well, did we know in advance this was going to happen? And the answer is yes. Well, sort of. You never know everything, but we did have some precursor information. We saw earthquakes, short, shallow earthquakes moving down rift. We saw deflation at the main crater and inflation down rift, where we eventually had the eruption. And we were able to raise the alert level and tell people before this actually started to happen. And then, in early May, we had this huge earthquake, a magnitude 6.9, and this makes it serious, right? This is no longer just movement, this is a real eruption. And so by the end of May, we had widespread fissures spewing lava through neighborhoods in Hawaii, going into the ocean, making huge clouds of noxious gas. They evacuated a bunch of people, hundreds of homes were destroyed, but the people weren't in them when they were destroyed, which is important. And highways were cut off. And ultimately, we covered a lot of land in lava. We made, we didn't. 900 acres of new land. And then as quickly as it started, the eruption began to subside. And so we watched as seismic activity tapered off. We watched as the whole system deflated. And SO2 emissions are currently lower than they've been since 2007. However, people continue to monitor these aspects so that if it starts up again, we'll know. And so the takeaway from this is we're actually really good at this now. We've gotten really good at predicting eruptions at instrumented volcanoes, which is every volcano in the United States and many around the world. And we can understand how the eruption is going to progress and let people know how they should take action. And so that's all. Thank you very much. Are there any questions? Yes.
Are they doing any development on the new land, or does it take a while for that land to be usable?
Yeah, that's.
It takes a while for sure. It's very. If you've ever walked on new lava, I've walked on new lava. It's really crunchy. It's not solid. It's sort of like walking on crusty bread. And so it's going to be a long time before that stuff is stable. But there is actually an interesting legal ramification where new land produced by the volcano is not owned by the United States federal government or by the state of Hawaii or anything like that. It's owned by the native Hawaiians. And so this is 900 new acres of native Hawaiian land.
Cool.
And you can like build a house on a lava dome. I mean, not like 10 years from now or 20 years from now.
It's not recommended, but there was a major 2014 flow that enveloped part of a town in sort of similar area. And people who owned that land, so this was land that was on land, you know, and then overridden by lava flows. People who owned that land rapidly came back, built houses on 6-foot stilts, you know, had a guy come in a dozer and like cram that lava down for driveway, and they have these little houses on stilts in the middle of a vast lava field. Sounds safe. Yes.
Have there been any studies on health factors that come into play with lava land or any of the aftermath of an eruption?
Definitely people talk about breathing the particulate for the ash, and especially breathing the gas emissions. And that's kind of what I worked on in this eruption. Is I was taking chemistry samples and analyzing them for things like fluoride content, because if you get too much fluoride from either breathing it as like acid gas HF or from drinking it, you can have health concerns like fluorosis. And that's more of a concern for livestock, but certainly a lot of people have like roof catchment systems, and that stuff will get into their water supply, so they have to get water from elsewhere. Yes?
So since you work at USGS, and since everywhere in the world has some sort of natural disaster, which natural disaster would you most want to live near, and which one would you least want to live near?
Good question.
Well, the volcanoes are more predictable than the earthquakes. So right now I live near the earthquakes.
I was thinking how long they knew about that hurricane. I was like, jeez, and you could pack everything you own by the time the hurricane showed up. I'm like, that's a lot better than an earthquake.
Yes.
So, Yellowstone supervolcano?
Yep.
Yeah.
Our main job, tell people it's not going to erupt.
Wait, really?
Really?
Why is that your job?
Well, because there's a lot of conspiracy theorists who are like, the government is hiding things from us. This seismometer went offline, and it means that Yellowstone is going to erupt.
But it is cool.
It is cool.
So is this not going to erupt as a practical matter, or not going to erupt ever?
As a practical matter, we would know potentially as much as years in advance if we had an activity ramp up in Yellowstone. If you're talking about the kind of big eruption, the world-ending eruption that the news talks about, we would know about that a long time in advance. And right now we don't see any activity ramp. This little geyser thing accepted. If you saw this little geyser in the news, exploded some cinder blocks and pennies out. It's the first time it erupted in ages, and people are saying, oh, Yellowstone's going to go off.
Has it ever erupted in a big way?
Yeah, so Yellowstone is actually a huge supervolcano that erupted 600,000 years ago.
And how often does it erupt?
Every 600,000 years.
Ish.
The last major flows were 60,000 years ago, but those weren't the world-ending type.
Okay.
Can we stop saying world?
It's not going to erupt.
Background
That's your
message.
job.
Climate change, we have another issue.
Are there bodies of studies being done for how to prevent eruptions rather than just predict?
So it turns out volcanoes are really, really big. But at the same time, there are a couple of things that people have been talking about. So one thing, there was this was a fascinating example of internal politics at I think NASA. So some people wrote a white paper about, say you wanted to take the Yellowstone volcano and make sure that it never erupted, how much geothermal plant type stuff would you have to put in to take enough energy out of the Yellowstone volcano to cool the whole thing off? And then they published this to like the USA Today, which people were really mad about because it's completely impossible in scale. But the concept is like, well, if you drilled a bunch of holes and you pumped cold water down them and you got hot water out and you turned it into electricity, could you cool off a volcanic system? And the answer is kind of no, because it's just too big. It's not at a human scale. But and the other interesting thing is people talk about diverting lava flows like in Hawaii. So once you've got a flow and it's flowing towards your house at 2 or 3 miles an hour, what are you going to do? In World War II, their answer was, well, what if we bombed it? And so this wasn't a good example either, because of course this didn't work. But they've tried things like...
They tried it?
No, they bombed lava flows in the 1940s. That sounds like it would work,
Keep
right?
going.
It didn't work. They've also done some things where they built berms and stuff to try to just route the lava gently around things, and that only sometimes works.
So Sarah will be providing extra credit links for some of these crazy stuff.
That's on
Read up on it.
Wikipedia.
We got time for one more question.
Maybe like in many other countries they cannot predict. I mean, like I'm thinking, for instance, of Guatemala, where people were killed. So I'm thinking, how is it expensive to predict?
No, it's an important concern, because if you don't have adequate instrumentation in place, you don't get all this information and then you can't predict. And the story about Guatemala, there's actually a really unfortunate story about that system, because the USGS Volcano Disaster Assistance Program, which is sort of our international arm, had actually assisted these guys in putting in a broadband seismometer, which is the fancy kind that allows you to see the long period earthquakes and the tremor and all the stuff that makes a volcano. And when they put it in, they gave them a SIM card, and the SIM card was going to be good for like 6 months. And then, like, 6 months go by, and we tell them, we can give you anything, but we can't give you money. And then the SIM card expires, and the broadband seismometer isn't actually transmitting. And then, several months after that, they have this eruption, which was totally unheralded. But maybe if that broadband had actually been in place and transmitting, then maybe things would have been different. And so then the question is, at the same time as we try to understand these scientific problems, how can we overcome these human problems?
Wow.
And so...
So does USGS only have equipment in the U.S.? We don't have this all over the world?
Well, so the USGS, the sort of main USGS, the Volcano Hazards Program, which I work for, is a US-based organization. But we have another arm, which is probably between 1/2 and 2/3 the size, which is people who are assisting people in other countries, not Japan, not Italy, not rich countries, but places like Guatemala, places like the Philippines. And they are sending people, they're installing instruments, they're trying to target places that would be really disastrous if they went off. And I don't know as much about their work, but it's something that we work on.
Question and none.
Yeah.